Five-step electronics. Today we're going to be talking about a thing called a variable resistor. What is a variable resistor? Well, a variable resistor is just a resistor that's variable, so it can be changed. This particular variable resistor is called a pot or a potentiometer, and I don't know why it's called that, but that's what it's called, I guess, because it looks like a pot. But let's demonstrate. Right? First, before I do that, let me explain how it works. I have this raggedy piece of aluminum foil. Right? So, these have 3 pins, while regular resistors have only 2. What's up with that, you know? I'm gonna mess up. I'm gonna say it's a variable resistor, but it doesn't even look like a resistor. Like, what is this? This is because the concept is different. The ends, like this one, let me point to it. This one and this one, the ones excluding the middle one, represent this side and this side. Now, if we connect one side to positive, right, that means this thing can be positive to some random number, right? Because the middle one is basically like a dial that you change with this, right? So it could be here all the way to over here, right? It slides based on where you turn it, right? But if this is positive, then this could be all the way positive, all the way positive, right? All the way right here, or down to some number that we don't know, right? So let me demonstrate, right? So put the dial up to positive, and then put one of the sides up to positive, right? It changes just a tiny bit, you know, just a tiny bit. Why? Because this is all the way positive, and this is some random number that we don't know. So how about we make that number something we do know, right? So let's make this all the way positive and all the way negative. Even though this is aluminum foil, we're going to pretend this is a resistor material. So even though they're touching, there's resistance between them, right? So it's not going to short out the circuit, right? So let's connect the middle or the dial to this one. One side to positive, that's going to represent this side, and the other side to negative. Turns off. Oh, yeah, it turns off, right? It's blinking because these aren't soldered on. These are just like wrapped around it, right? So they come on and off. So the dial seems to be here or in the middle, because a positive plus a negative equals 0. So it could be either here or here. In between there or there, right? So let's turn it. It seemed to be all the way negative, right? So this is negative. No, this is positive. So this is all the way over here. When it's on, it has to be positive, right? Because this is wanting it positive. This is 0 and this is negative. How do I know it's negative? Let me show you. I have another LED, but this one I'm gonna hook it up so it wants negative, right? So I just turn it the exact opposite way, right? Positive, 0 because nothing's on, negative. See that? Exactly what I said here with the raggedy aluminum foil, right? Cool. This is pretty simple though. I mean, it's just a volume dial. Who cares? Well, let's get a photoresistor. Photoresistor is just a resistor that changes based on light. So let's hook that up. Hook that up to positive and get. I like this one. It's bigger than the other one. So let's hook this up. Just like. As you can see, it's on, but it dims just a tiny bit when I put my finger on it, because it's letting less light in, right? And if I just let it out or get my flashlight, where's my flashlight? if I get my flashlight, then it should come a bit on. It comes on ever so slightly, right? This is because the photoresistor loses resistance when it comes in contact with light, right? But then gains resistance when it's not exposed, when there's no light. Meaning, when there is light, the light will come on, and when there's no light, the light will turn off, basically. But it's so small, you can barely see the change. You can barely see it. So what do we use? A transistor. Yeah, correct. All we gotta do is just plug it in. The photoresistor as the input. We get this. Hook this up to, I guess, positive, and then hook this up to negative. Now, I don't like this LED. Let's use this one. Did I hook it up right? Nope, I didn't put it in the right polarity. Longer side must go to positive, and the shorter side must go to negative. Right? So we got that. It seems to do the same exact thing, except for it's a little brighter. Well, just like we have with the potentiometer, with the pot example, this thing is either positive or nothing, right? It's positive or the unknown. So let's make it either positive or a bit negative with a resistor. This is a 470 ohm resistor, right? So let's see if this one works good. So just with the input, just put up to negative. Alright, seems to go off. Let's get the flashlight. Let's see what happens. Too much negative. If there's too much negative, then the thing would just not come on, because the negative's overpowering the positive. Alright, this one seems promising. So let's move this one over here. See it? And it should come on a little bit more. Yep. Well, let's change it to over here with the output, right? So we have it like this. Does that do any good? A little bit. It does a little bit good. Whoa. Let's go back. Alright. So this seems like it's good. Alright. Sometimes you need to turn around the transistor. I went into a lot on the last video about transistors and how they work and everything. So you should go check out this video to fully understand this particular tutorial. Right? But this one, if you turn it around, it'll work better sometimes. Right? So it seems to be working pretty good. Cool. But that's not how, photoresistors, as you can tell, these are probably used in nightlights, because they detect light, they change resistance, and they can control a light. But this isn't how nightlights work. They don't go dimmer when there's darkness and go brighter when there's light. That's the exact opposite. That just defeats the purpose. What we need to do is change it so that it comes on when there's darkness and turns off when there's light. So I'm gonna get a little wire connected to the output of this. Right? It's the same exact thing over here. Right? What I have this? Oh yeah, I had to connect the negative. Change the polarity. There we go. Same exact thing. Except for this time, I'm gonna add a resistor. Let's bring back that 470 ohm resistor, right? So let's, I don't know, put this up to negative. Why would you do that? You'll see. So, didn't really seem to do much. It does the same exact thing, right? But this time it has a little bit of negative in it. So if it has negative, let's hook up the LED so it takes a negative, right? Seems logical. I don't know. The exact opposite is happening. But why? Because when there's light, right? Like right now, what happens is the positive goes through. But then this negative. But then the LED wants negative. The positive goes through, but it wants negative, so it doesn't come on. But when this turns off, because when it's blocking, the resistance goes up, so less positive is going through, right? So the positive, so no positive is going through, right? So this negative resistor has the chance to step up. It overpowers the tiny bit of positive that's going through, and this one's negative, right? So it comes on, does the exact opposite. So I can hook up this LED and the opposite of this, the other one, the way we had it before, and we have the same exact effect that we had last time with the pot, with the potentiometer. I can have this thing. There's light. There's light. The blue one comes on, and there's darkness. This one comes on. Of course, you can add more power and fiddle around with these resistors to make it more sensitive or less sensitive or whatever. But I'm gonna move on. Now we have the speaker, not a speaker, a microphone resistor. This changes resistance based on sound or air pressure, right? So let's take away all this blah blah blah, right? I'm gonna leave the transistor because I'm gonna need it, right? But I'm gonna just hook this up here. We're gonna use positive again. So we just hook this up. Can you see that? Can you see it? When I'm blowing it, it changes a little bit. Changes just a little bit. So let's do exactly what we did last time. Use the transistor. So I'm gonna move this over with the transistor. Get this. And again, it's just brighter. So let's do exactly what we did last time. Add a resistor. I'm gonna use this 10 ohm resistor again. Plug it up with the output this time though. Negative right here. If something not going right. Or is it the input? Let's try it on the input. Maybe on the input. You see that? Ah! See? Comes on. Based on my speech. And we can keep amplifying this. And hook it up to a speaker or whatever. And you got your own homemade microphone. Let's see if we turn this around, see if it get bigger like last time. Nah, it came smaller. Let's go back. Cool, right? So let's learn what let's do what we did in the second video and use 2 of these resistors in series, so we'll make the resistance more. Hook this up, back up. Is it negative? Yeah, it's negative. Something like that. Oh, and connect these 2. Now it's a little more sensitive. And then we can use an op amp or operational amplifier to multiply this by 10, 20 or whatever. But I'm not gonna get into that this video. I'm gonna save that for the next video. Right? So stay tuned for the next video, and I'll see you later.